In generalized binomial expansion, we can let the exponents be fractions. And this will be useful if I want to approximate a square root. Like, for instance, the square root of 11 could be written as 9 plus 2 to the 1/2 power. Try to make that first number the perfect square that's closest to 11, but still less than it. And now I'm going to do a binomial expansion. When you have fractions, it's a little bit unusual. In a regular binomial expansion, like if this was not a half, but a 4, it would be 9 to the 4th, 2 to the 0. Well, this is going to be 9 to the half times 2 to the 0. And the second term, the exponent on the 9 always goes down by 1. When you take away 1 from a half, you get negative 1/2. And when you take away 1 from that exponent again, the negative 1/2, it becomes 9 to the minus 3/2. And I'm just going to go 4 terms because these actually go on infinitely. Say dot, dot, dot. We'll just do 4 terms to get a good approximation. Now the coefficients, the first coefficient, I'll kind of call it something funny. I'll call it 1/2 C0. Anything C0 is 1, so we'll put a 1 there. The second coefficient I'll call 1/2 C1. Anything C1 is just itself, so I'll just put a half there. The third coefficient is a half C2. Anything C2 is the number times 1 less than the number over 2, which is a half times negative 1/2 over 2, which is negative 1/8. And half C3, anything C3 is the number times 1 less than the number times 2 less than the number over 6, which becomes negative 3/8 over 6, which becomes negative 3 over 48. Sorry, positive make that, becomes 1 over 16. So these terms, 9 to the 1/2 is 3, so this first term is just 3. 9 to the negative 1/2 is 1/3, so 1/2 times 1/3 times 2 is just 1/3. 9 to the negative 3/2, recall that 9 to the negative 3/2 is 9 to the 3/2, 1 over 9 to the 3/2, but 9 to the 3/2 is the square root of 9, and then raised to the 3rd power. In other words, 9 to the negative 3/2 is 1 over 27. So we have negative 1/8 times 1 over 27 times 4, that's the 2 squared, and the 4 and the 8 cancel out, we get negative 1 over 54. And this last term becomes 1 over 16. 9 to the negative 5 over 2 is 1 over 9 to the 5/2, is 1 over 3 to the 5th. 3 to the 5th is 243, and 2 to the 3rd is 8. And when I cancel that out, I end up with 1 over 486. And that's my last term. With common denominators, this comes 1,612 over 486, which is a nice approximation. If I do that on my calculator, I get 3.316872 something, and if I square that, I get 11.0016427. And the goal was the square root of 11. So this is a nice rational approximation. Again, it relies on us basically saying that 1/2 C0 is 1, 1/2 C1 we're going to treat as 1/2, 1/2 C2 is negative 1/8, and 1/2 C3 is going to become positive 1/16. You should think about, what if I wanted to go one more term? That's something for you to think about.